right, so let's try our next example. So this time, I'm giving you an implicit function, but it's the exact same thing. Let me talk about this phrase, consider the differential equation, because you haven't seen that before. There's actually a course in college in math called differential equations. I've taught it at Brookhaven. It's a whole course. You could actually take several courses over it. In this class, we just dip our toe in the subject of differential equations. Really, the definition of a differential equation is an equation that involves a derivative. So when you see this equation, do you see something that indicates a derivative? Yes. Therefore, it's a differential equation. Okay, that's all it is. Don't make it sound harder than it is. All right, so given this equation that we're giving you the derivative, essentially, not the actual function. Write an equation for the line tangent to the graph at x equals 3. So this time, do we even know what the function is? Do we know what y is? No. So we can't even put it in the calculator in this case, like we could have in number 1. So and that's why differential equations is so important as a subject, because there's some phenomena that we only know what the rate is, how something's changing, but we don't know what the actual function is. So can I still approximate a function if I know its rate? Yeah, by using the equation of the tangent line. So let's review. If I want the equation of a tangent line, I need a point and I need my slope. Do they give us the point?
3,2.
3, 2, perfect. They're going to have to give me the point because I don't have the actual function. All right, now the slope is the derivative evaluated at dy at 3, 2. They gave me the notation dy dx. Maintain your notation that's given. So how we denote slope, so remember dy dx, if we're evaluating at a specific point, remember we put a vertical bar. At the bottom, we say at the point 3, 2. Okay, that's kind of how we set up at the top. We said like f prime of 0. That's how we write this at a specific point with dy dx notation. So now we've done this before. Wherever you see an x, put in 3. Whenever you see a y, put in 2. Now, I always like to label everything. If this is a free response question, I like to label, okay, here's my tangent line. Y minus my y value equals slope times x minus my x value. Okay, remember I told you that your tangent line, if I just ask for a tangent line, that's fine, but we're going to be using this tangent line to approximate. Here's what I would not do. I would not distribute the 1/3. Do not distribute the 1/3. All you need to do is just bring over the 2. So if you actually want to start writing your tangent lines like this, you can start writing your tangent lines like this. Slope times x minus the x value plus the y value. Do not distribute the 1/3. Because now watch, if I want to now, my whole goal is to approximate the value of f of 3.3. Label everything that you do. There's a thing we say for the free response, no naked answers. Dress them, okay? So f of 3.3 is approximately, now take my tangent line equation, and where I see x, just replace it with 3.3. And you could just stop right there. You do not have to simplify that if it is a free response. There are some cases where you have to, they will tell you, or in a multiple choice, you will have to. But I'm going to stop right there to model for you. Stop, please, don't simplify. It takes time, and that's where you tend to make mistakes, correct? So don't do it. All right, I'm going to pause right there. Any questions on number 2? Not too bad, right? It's not.
Wait.
It's just, yeah, say.
This seems like one that you would want to simplify.
Why?
Because
I mean, you would want to because you're so used to it, right? But yeah. Is this right here, is this a numerical answer? That means, are there any variables in there?
No.
No, it is a numerical answer. Once you get a numerical answer like that, you don't have to that is the answer. So on the free response, they're not interested whether or not you can do arithmetic. They're interested in, do you know the calculus? Okay, is that all right, Zabe? Okay. If it was multiple choice, though, they would have the simplified answer. So don't forget how to simplify. On my answer key, will I have the simplified answer typically? Yes. As long as your answer is equivalent, you're good. Or unless I say to specifically simplify.